All right, so now we're going to talk about scientific notation. So the first question is, what is scientific notation and why do we use it? So it's pretty much all it is an easier way to write larger numbers. So numbers like 2, 6, 2, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It's hard for us to visualize those numbers with all those zeros, or numbers like 0.00000000001, 2, 3. It's like those numbers, it's really hard for us to conceptualize and understand how big or how small those numbers actually are. So scientific notation helps us with that. And it's written in this form. So it's written like this, which it really looks like something like 3 times 10 to the 6th or something. What's important is that this C value, this C, has to be between 1 and 10. If it's bigger than 10 and smaller than 1, then it's not proper scientific notation. Okay? So like my example, I used a 3. Okay? So that's improper scientific notation. If I used 30, that would not be scientific notation. So it has to be between 1 and 10. That's a biggie. Okay? So we're going to first start by converting from standard form, aka regular numbers, into scientific notation. And there's 2.5 steps to do that. Let's go over those. The first thing is we're going to find where the decimal point is. So we're going to find where the decimal point is. So we're finding where the decimal point is. Or would be written, really. So where it should go in the problem. Next, we're going to move that decimal point. So once we figure out where it should be, aka to make the number between 1 and 10, right? Because we want to bigger than 1, less than 10. Now we're going to move the decimal point. So we're going to move the decimal point to the right or the left. The right or the left to make the C value greater than or equal to 1 and less than 10, right? So we've talked about that a few times. Now here's the big thing. If we move it to the left, the exponent is positive. If we move to the left, so if we move it to the left, our exponent is positive. So if we move it to the left, exponent is positive. Okay, so that's a biggie. So if we move it to the left, our exponent is positive. If we move it to the right, so if we move it to the right, our exponent is negative. Okay, so that just kind of helps us figure out which way it goes and which is which. All right, so now let's start practicing some of this, okay? So looking at letter A, the number 2,000. Okay, so remember we said the first thing we need to do is identify where the decimal place should go. So the decimal place should go right here because we want the number, our C value, remember our C value, to be greater than 1 but less than 10. So 2 falls right between that. If we put it here, it would be 20. That would work. So then, now we have to figure out how many times do we move the decimal place. So we start on the end and we moved it once, twice, 3 times. So we moved it 3 times and we moved it to the left. So that means our answer should be 2, because that's our C value, times 10 to the positive third. Again, because we moved it to the left, which means it's positive, and we moved it 3 times. Okay, so we're going to do that one more time. So we have to figure out where our number goes. So we can't put it here because that would be greater than 10. Can't put it here because 442 is bigger than 10. 44 is bigger than 10. So we have to put it right here. And that means we moved it to the left, and we moved it 1, 2, 3, 4 times. So that means our answer is now 4 point, and we leave the rest of those decimals, even though we kind of, not that we got rid of them, but we put whatever the number is, and then it's to the positive 4. Okay, I'm going to go over to D, and then I'm going to let you do C and F on your own, okay? So we're going to do D and E right now, and then I'm going to ask you to pause, and then you'll do C and F on your own. Okay, so D. Let's look at that one. So again, we want our number between 1 and 10. So we're going to move our decimal place until we get it between 1 and 10. So we move it once. That's still less than 1. We move it twice. 7 is smaller than 10. If we moved it to the 6, that would be 76. So that's bigger than 10. So in this case, we moved it twice, and we moved it to the right. So that means our exponent should be negative. So then our answer is 7.69 times 10 to the negative 2. Okay, and again, that's because we moved it to the left, so it's a negative number. Let's do one more. Okay, so we moved it once, still smaller than 10. Twice, still smaller than 10. 3, smaller than 1. 3, smaller than 1. 4 times, smaller than 10, but bigger than 1, so that's good. So we moved it to the left, so that means it's negative, and we moved it 4 times. So our exponent is now 10 to the negative 4th, and our C value is 9.1. Okay, so I want you to pause this video, and I want you to try C and F on your own right now. Okay, so please make sure you check your C and F answers. Okay, and I showed my work and my rationale behind it, but if you have questions, please make sure you're asking those in class. So now that we've mastered going from standard into scientific, now we have to go the other way. So now we have to move from scientific to standard. Okay, so we're going to do that first by moving our decimal. So we're going to move the decimal. So we're going to move the decimal, the direction. So we're going to move the decimal, the direction, and the number of the exponent. So what that means is if it's a positive exponent, we move to the right. So in this case, if it's positive, we move it to the right. So if it's positive, we move to the right. And then if it's negative, then we move it to the left. Okay, so it's kind of like the opposite of the above process, right? Because pretty much we're undoing scientific notation. So it's the opposite of the above process. All right, so we are going to start by putting whatever your C value is. It's like whatever this number is out front, that's what I'm going to start by putting there. So I'm going to put a 3 here. And then this decimal is a positive 2. So that means I'm going to put 2 zeros to the right, right? So I have my decimal here. I'm going to move it once, twice to the right. So since I have nothing there, that means I put implied zeros there. What this really is 300. Okay, because I take my decimal from 3 point and I move it twice, and since there's no numbers, we add zeros. Okay, so we're going to start again, B, by doing 2.4. And then it says that we have to move this 4 times, and it's positive, so we move it to the right 4 times. So move it to the right 4 times. So we go once, twice, 3 times, 4 times. And since there was nothing there, we add zeros. So now this is really 24,000. Okay, so we're going to do the same thing here on this side. So we're going to start by putting 6 down. Because it's negative, I'd probably put the 6 here. Our decimal starts here, but we want it to go to the -3. So that means we move it to the left 3 times. We move it once, twice, 3 times. So our decimal place is here. We fill in zeros. And that means our answer is actually 0.006. Okay, let's do one more. So again, our decimal is negative. So that means we go to the left twice. So we start with a 9.5. And we move it to the left once, twice. That means our decimal's there. So you have 0.095. Okay. So let's keep on going then. Okay, so let's keep on going. We're almost done, I promise. So in example 3, we want to know, are these in scientific notation? Yes or no? And if they're not, put them into scientific notation. Okay, so let's look at these. Remember, our C value, our C has to be less than 10, but it could be 1 or greater. So looking at this, is 25 between 1 and 10? No. So the answer is not in scientific notation, so I'm just going to write not. And then we have to move it. We're moving it to the right. Since we move it, just kidding, sorry, we move it to the left. So we move it to the left. And so we're moving it to the left, we have to add 1 here. So that means that our answer is 2.536 times 10 to the 4th. Okay, so one more, well, 2 more. B, is 900 between 1 and 10? No. So we're moving it to the left. We're moving it to the left once, twice. So then we have to add 2 here. So in that case, it'd be 9.0 times 10 to the 0, because -2 plus 2 is 0. And if it's a 0, that's okay. That's just what we write. One more. So oh, don't forget to write not there, is 0.236 between 1 and 10? No. And in this case, we're moving it to the right. So we're moving it to the right, so that means we have to subtract 1. So now it's 2.36 times 10 to the third. Okay? So now a lot of you are going to be using calculators to figure these out because that's just what you're going to do. So calculators use a special function, and it's called EE notation. So this is the way. So this is a way that a calculator displays a very large or small number in scientific notation. And that's because calculators only have so many things that they can show you, right? So they can only display so many numbers. So if we do that times 10 raised to a power, that's like 4 digits that it's taking up of the decimal point or your zeros. So it tries to do that with one thing and it calls it EE. So it's just another way to say times 10 to the power up. So again, it's just another way of saying times 10 to some power. And whatever it says you move, that's what you move the decimal place. To the right or left that many places. Right, so thinking back to before, so what this is going to look like, it's going to be like 3, 7, 2, and then it will be E, 6. So what that means is that, it'll be 3.72 E6. So that means we're going to move that decimal place 6 places. So it would be 3, 1, 2, and then 3, 4, 5, 6. So we'd have 4 zeros after there. And then that would be our number. Or if it's like 3.72 EE negative 4, we'd move that then in the negative way 4 places. And it'd be 0, 3, 7, 2. Okay, so just some quick examples there. And again, it's because the calculator can only hold 10 digits, so it has to save room. And therefore, the number can be cut off, which means your last digit may have to be rounded. Okay, so let's look at a couple of examples here. So letter A, we have 4.183298 EE7. So remember, that means that we move this 7 places to the positive, which means move it 7 places to the right. So move it once, twice, 3 times, 4 times, 5 times, 6 times, and then a 7th time would be 0. So that means our answer is 4, 1, 8, 3, 2, 9, 8, 0. And then we'd have to count how many places do we have. We have 3, 6, 7, 8. So this is 8 digits, so that's an okay number, and it'll display that. B, though, let's look at B. B is to the negative 6. So that means we're moving to the left. So we're moving once, twice, 3 times, 4 times, 5 times, 6 times. Okay. 5 times, 6 times. So that means we have 0.00000. 2, 3, 4, 5, 1, 2, 0, 5, 6, 3, 3, 1. But remember, your calculator only shows 10 digits. So it only shows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it only shows up to here on your calculator. So what is our calculator actually going to display? It's going to display 0.1234521. Now, why did I say it was going to display this 1 here? Well, I said that because after the 0 is a 5. And remember, 5 and above rounds up. So the 0 would get rounded up to 1. Okay, so I want you to pause right now and try C and D on your own. Okay? All right, so hopefully you're checking your answers and they line up pretty well with my answers. Okay, so I think C was kind of straightforward. However, D was a little rough because we had to move it to the -7. And remember, our calculator only displays 10 places. So we had to stop it here after in between the 4s. So then this is what the calculator would see. Okay? One more. I promise we're almost done. All right. So now sometimes you'll be given information in a table like this, and then we have to order these places from greatest to least. So what we're going to do with that is we're going to look at these exponents. Okay? So we're going to look at these exponents, and we're going to put them in order from least to greatest. Okay? So which city has the smallest exponent? Right? Because the smaller the exponent, the smaller the number is, right? So in this case, it's Goodstein Village with an exponent of 3. So that's what we're going to put. From least to greatest is Goodstein Village. If you run out of room, just write it underneath or something tiny. Okay? So we've chalked off Goodstein Village. What's next after 3? Well, then we have a 4. So we have Gilroy County. Okay. And then after 4, I see 2 6s. I see a 6 in Furmanville and Myers City. Right? So then that tells me I should look at my C values after that. So I should look at my C values, 5 ones with the same exponents. And then of those C values, which number's smaller? Is it 2.4 or 2.5 that's smaller? Okay, so in this case, it's Myers City that's smaller. So that's what we're going to put first. So Myers City. And then Furmanville. Which means we've crossed off 2 more things. And that leaves us lastly with Navetown. Okay, so these were, I would think, populations based in that year. So obviously from 2000 to 2020, the population has grown. So now I want you to order them from least to greatest for the year 2000. So now we're looking at this box and determining what the order should be. So I want you to pause and try that on your own. And remember, we're going from least to greatest, okay? All right, so now I've put them in order from least to greatest, so make sure you're checking your answers. Okay, I think those middle 3 all had an exponent of 7, so you really had to look at the C value and then put those in order accordingly. Okay, so I know this was a lot, and we'll go over this a couple of days in a row, so don't stress too much, okay?